Everyone, I hope you all are fine. So let's start our today's session. As I'm reminding you, in my previous session I have explained how to convert carbonated and sulfide ore into a metal oxide with the help of the process of calcination and the roasting. So when we get finally a metal oxide, how it is to be converted into a free metal, that is I am going to discuss with you today. That method which we have to follow to convert metal oxide to the metal, that method is to be a reduction. So most probably the reduction is to be done with the help of carbon. Carbon is a well-known reducing agent. So here I have written the few examples for you, like ZNO. If you are using carbon, carbon will reduce ZNO to Zn and carbon monoxide that comes out. Same it happens with FeO plus C, then it will convert into Fe, PbO plus C, that will convert into Pb, and CuO plus C, that will convert into Cu. So in this way we are getting all the free metals by the reduction reduction with the help of carbon. Okay, but here the few points that you have to understand: merits and demerits of using coke as a reducing agent. Coke, it means we are talking about the carbon. Okay, so the few points I have written for you, that is very important to understand. Coke means carbon is generally used as a reducing agent because it is less costly and it can reduce zinc oxide and oxides of other metals below zinc in the activity series. Means those metal oxide which are present below the zinc and zinc oxide, carbon have the capability to reduce them. Okay, now let's see here the next point. Coke is not used to reduce the oxides of active metals like Na, K, calcium, magnesium and aluminium. Already I have told that because all the active metals, they have a great affinity with oxygen and chlorine, so they are not able to reduce with the help of carbon only. Okay, so we have to use the electricity in this method, so that a reduction is to be done, that we call it, this is electrolytic reduction. We will also discuss about it. Now this is one disadvantage of using carbon as a reducing agent. So this becomes a main disadvantage of carbon as a reducing agent, because it is not capable to reduce all the metal oxide, that small traces of carbon are added to the metal as a impurity, that you must know that. Now the next point that you have to understand: reduction of metal oxide with the carbon monoxide. So in that case we can use carbon monoxide as a reducing agent also. The oxides of iron and oxides of other metals below iron in the activity series, here we are talking about the iron and the below iron, that can be reduced with the help of carbon monoxide. So you see here, like Fe2O3 plus CO, we are using carbon monoxide as a reducing agent here, so that will convert into Fe. Lead oxide plus, if you are using carbon monoxide, so that will convert into lead easily, that will convert into a lead. So we can use carbon monoxide as a reducing agent also, that you must know that. Okay, let's talk about the another thing, that is carbon monoxide cannot be used to reduce the zinc oxide. Means zinc oxide can be reduced only with the help of carbon, not with the help of carbon monoxide. And the oxides of metal above zinc in the activity series also, that is carbon monoxide cannot reduce ZNO, Al2O3, MgO and CaO. So here we have discussed about the action of carbon and carbon monoxide as a reducing agent. Let's talk about the reduction of metal oxide with aluminium. So whenever where the carbon and carbon monoxide doesn't work as a reducing agent, then we can use aluminium as a reducing agent also. So the aluminium is used as a reducing agent when carbon cannot reduce the metal oxide. Okay, chromium, manganese, titanium, vanadium, molybdenum and uranium metals are obtained by the reduction of their oxide with the help of aluminium powder. So aluminium is very helpful for the reduction of these types of metals. Okay, now let's see the next point which you have to understand, that suppose you are having manganese dioxide, you are using aluminium as a reducing agent, then we get a free metal and Al2O3 that comes out. Here we have to understand that reaction is highly exothermic, so the metal which we are getting in a free form, that will occur in a molten state. That's why I have mentioned here a liquid form. So this highly exothermic, so the metal is produced in the molten state. Same it happens in case of chromium trioxide. So this is Cr2O3, aluminium you are using as a reducing agent, then Al2O3 plus chromium we are getting in a liquid form. Okay, now the next is to be reduction of metal oxide with aluminium is known as aluminothermy or the thermite process. We just call it thermite process. Okay, thermal word that relates with the heat. Okay, now aluminium is a very expensive metal, that we must know that. Therefore it is not used to reduce the metal which are less expensive than the aluminium. So suppose we have to reduce that metal, those are cheaper than aluminium, here the aluminium will not used as a reducing agent, that we must know that. Okay, now the next is to be aluminium is used when it is required to produce a small quantity of even a cheaper metal free from carbon. Okay, so here we have studied about three reducing agent. These are carbon, carbon monoxide and aluminium. Okay, so these are most probably the reducing agent which are to be used for the reduction of metal oxide. But you see here the last point which I have written for you, this is a very important up to the standard of 12th standard study, that is of the choice of reducing agent for a specific metal oxide is to be done with the help of Illingham diagram. So this is the main important thing which we have to study in class 12, means which specific reducing agent is to be used for the reduction of specific metal oxide, that is to be decided only with the help of Illingham diagram. So what the Illingham diagram explains and what the information it provides us, that will help you to choose the reducing agent for the reduction of metal oxide, that we will discuss in the next session. That's all for today.